we are talking about parts 1 and 2 of our nutrient cycles. Part 3 is the nitrogen cycle. So, does anybody know about the law of conservation of matter? It might not. You probably know it, just not under that name. Essentially, matter cannot be created or destroyed. Essentially, we have so much nitrogen in the world, in the universe, and you can't make more nitrogen, you can't destroy nitrogen. So, this is the law of conservation of matter. Essentially, matter is conserved in all chemical reactions. So even though one substance goes into a chemical reaction and a different substance comes out of the chemical reaction, there is still the same amount of atoms that went in as came out. Some might be what we wanted, some might be byproducts. Y'all are going to get some really discounted art skills today, I think. All right. We'll back up. So that's the law of conservation of matter. Today and tomorrow, we are talking about biogeochemical cycles. Biogeochemical cycles. Chemical cycles that are part of living systems and non-living systems. Essentially, our chemicals go through their cycles, and in that time, they are sometimes interacting with living things and sometimes interacting with geological things. So, biogeochemical cycles are essentially nutrients cycling through the environment. Nutrients cycling through the environment. I'm going to check something really quickly. Make sure I'm not double dosing you on a lesson because it seems eerily familiar. All right, so, I know what it was. Biogeochemical cycles are matter circling through the environment. In the Earth's spheres lesson on Canvas, we went through the water cycle. The water cycle is a biogeochemical cycle. So our second cycle we're going to talk about is the carbon cycle. We talked about why carbon was such an important aspect of life and how often that carbon comes in handy when building things like our biological macromolecules. And so now we're going to talk about specifically how carbon circles through the Earth. We're going to start up here with the atmosphere. Carbon is in the atmosphere. Oh, why is there a bug? well, as CO2. Mainly, it's in there in some other chemical compounds, but CO2, carbon dioxide, is normally how we find carbon in the atmosphere. There are a bunch of ways that it can get there. So, one of the more simplistic ways, we've got carbon down here as fossil fuels. Through a process of mining, it is brought up for human use. And as we burn fossil fuels, that gets released as carbon dioxide into the atmosphere. Carbon is also trapped in sedimentary rock. So a lot of carbon is kept in kind of a solid form, trapped in different rock sources. So that sedimentary rock, we're going to say we've got the ocean. We've got a river. So there is an exchange between sedimentary rock and the ocean. As rock is dissolved or weathered away, some of that carbon dioxide or some of that carbon gets dissolved into the ocean, and some of it is deposited onto rock, just depending on how, like temperature and all that kind of stuff. There is something called the ocean atmosphere exchange. Essentially, there are multiple different sources that we don't have to go into about how carbon gets from being dissolved into the ocean to being dissolved in the atmosphere. Told you I had phenomenal art skills. Volcanic eruptions and other geological processes bring carbon from sedimentary rock into the atmosphere. So as that sedimentary rock melts or is spewed directly out of volcanoes and other processes similar to volcanoes, hot springs, all that fun stuff, it is released into the atmosphere as CO2. Those little two dots are bugging me. That didn't help. All right. So another way carbon gets into the ocean is through runoff and weathering. So as water runs through a river, those rocks are kind of melted and dissolved and eroded, and that carbon gets released into the river, and the river spits it out into the ocean. Now I've got some fun stuff. Down here we also have soil and soil organisms. Everything from our detritivores and decomposers, so the things that break down stuff, all of our worms and bacteria and all the fun little critters that live in the soil. So they get carbon from decomposition. Essentially, the breakdown of organic matter. As they consume it, they get all the carbon on the inside, and that's how they get it. And then there is another process called cellular respiration. Cellular respiration, that's 2 words. Essentially, I don't know. It is the process that undoes photosynthesis. There we go. Cellular respiration. It is the process that we are all going through right now to break down what we ate for lunch and then exhale carbon dioxide. So we also have, actually I'll make it green, our land plants. So all of our plants on Earth, they take carbon out of the atmosphere through photosynthesis. They transfer carbon, I'm running out of space, to consumers. So, us, we ate something that had to do with plants for lunch. We take the carbon that was in those plants. Now we have it. Now plants and consumers both carry out cellular respiration. So cellular respiration gets carbon into the atmosphere in 3 different ways: through plants, through plant eaters, and through soil organisms. It kind of got messy. Does everybody follow the carbon cycle? Cool. There's some key terms in there I want to hit. Key terms I want to hit. The first being primary producers. Our primary producers are plants, algae, and I'm going to throw bacteria in here. That produce their own food. And that is the process of photosynthesis. Now, chemically, photosynthesis is essentially taking 6 carbon dioxide molecules and 6 water molecules and taking sunlight and using the energy from the sun to create sugar and oxygen. Now, the opposite process we said was cellular respiration. And that is taking sugar and oxygen and turning it into carbon dioxide, water, and energy. It is why we need to breathe oxygen. The oxygen we breathe allows us to break down sugars. When we break down sugars, we get carbon dioxide, which we exhale, and we can use that energy. Any questions about the difference between photosynthesis and cell respiration? Did I shut that off? Another key term I want to hit before we get into the phosphorus cycle is the idea of decomposers. Decomposers break down dead organic matter. When we think about our producers, consumers, our normal food chains, we don't often think about our decomposers being such a critical part of those. I just wanted to make sure that I gave them extra attention. Also, the carbon cycle has a missing sink. So if you think about, I'll come back to this. If you think about this up here, right? Every time that carbon is taken out of the atmosphere, it is considered a carbon sink. And every time carbon is put into the atmosphere, it is called a carbon source. So there is a carbon sink that we are missing. Essentially, our idea of the carbon cycle is incomplete. One to 2 billion tons of carbon that we have put into the atmosphere is unaccounted for. We don't know where it is. Some scientists think it's in northern forests. So there's like giant stretches of forest in northern Canada. So some people think that a lot of that carbon is there, and we just don't know how much. But essentially, we don't know where all this carbon is going because we have put so much into the atmosphere, but not all of it stayed there. But it's also not in our calculations for where else it could be. Any questions about the carbon cycle? Now, let's have some fun with the phosphorus cycle. The phosphorus cycle mainly takes place in the atmosphere and oceans. Oh, no, sorry, not atmosphere. I read it wrong. Lithosphere. So the opposite of the atmosphere. We're talking about the layer of rock at the underneath the Earth's crust. Lithosphere. there's two main subsections. Even though it doesn't really take place in the atmosphere, we're still going to write it. Just so there's some continuity between our two cycles. So, we'll start with mineable rock. So there's a bunch of phosphorus stored in rocks that we are able to mine. We will take that rock, we will mine it, and create fertilizers. There's a lot of phosphorus in rivers because we have the pollution from the fertilizers. So runoff from farms after we've watered it all up, it rains, all of that extra fertilizer gets pushed into rivers. But also through weathering. So that process of slowly breaking rock down over the course of a couple, decades. So the phosphorus that is in this rock could eventually end up in the rivers, but we are contributing to the amount of phosphorus in rivers at an alarming rate. That is why a lot of fertilizers are monitored and regulated, so we don't get excessive phosphorus put into rivers. So, get our ocean back here. So we've got our runoff into rivers, or into the ocean. This is the ocean. So we have producers, consumers, and decomposers that all exist within oceanic populations. So let's see. Our producers will get decomposed if they die, so they give phosphorus that way. But also they will give phosphorus to the consumers when they are eaten. Consumers will also be decomposed. And decomposers will also be, consumed. I'm sorry, I'm missing a line. Decomposers. So after the process of decomposition, it will release phosphorus into the water, though then the producers will take in that phosphorus and then be able to either put it back into decomposers or through consumers decomposers. Phosphorus from the ocean can also be transferred into sedimentary rock. And then there is a process called uplift. It is a geological process that gets sedimentary rock and kind of lifts it up to the point where we can mine it. And that's like some complicated geophysics stuff. Essentially, rock from the like base of the lithosphere gets heaved up by geological processes, and then we are allowed to mine it, or allowed to, but like are able to. There's also a mini cycle within this cycle. So we've got more uplift into soil. From soil, that can go into land plants, because plants take phosphorus up from the soil. That's why we use it in fertilizers. If land plants die and decay, decomposers will break it down. Or if land plants get consumed by consumers. Sorry, I've got to put it sideways. So consumers can get phosphorus from land plants, and decomposers can also break down consumers. That one's something we're a little less familiar with. Does anybody have any questions about the phosphorus cycle? All right. There's a really, really key term that I want to associate with the phosphorus cycle. I'll let you get this down first. Then. There is a process called eutrophication. Eutrophication, and it is a really big deal when we talk about environmental science. Essentially, eutrophication is an overgrowth of producers, usually algae, due to an increase in phosphorus. Have you ever been driving or riding down the road and you see like somebody's like got a pond or a lake, and the entire top of that pond is just covered in like green slime? Yeah. That is because of eutrophication. Essentially, usually those ponds are around farmland or around a garden that uses phosphorus fertilizers. So essentially, so much extra phosphorus has been pumped into that water system that those algae thrive. But when there is so much algae in an ecosystem, when this is in extreme cases, so we get something called hypoxia. Which is essentially drastic decreases in oxygen, which creates something called dead zones. So essentially, we've got so much algae covering the top of this pond that even though plants release oxygen when they carry out photosynthesis, that oxygen is being released into the air rather than the water. So that water has little to no oxygen in it, so nothing can survive. So those ponds with those green scums across the top of it, if not taken care of and if allowed to get bad, all of the fish, all of the plant life in that water can die. They're fighting a really big dead zone off. I think it's in the Gulf of Mexico. There's a huge dead zone because there was a gigantic algal bloom after an oil spill. There's so much phosphorus left over that it killed so many fish and created a big deal for like local fishermen and then like local economies because they didn't have their major source of income anymore because all of the fish in that area died because of eutrophication. Anyone have any questions? All right, I believe there is an exit ticket. There is not an exit ticket. All right. All right. So that is my lecture for the day. So if you do think of any questions, please let me know.